Hello everyone, my name is Nidhi Chauhan. I'm assistant professor in SGVU-Pharmacy, which is a part of the Suresh University Jaipur. Today's topic is a carboxylic acid. It is the first fifth unit of this fifth unit of your syllabus of a particular PCA in pharmaceutical organic chemistry first. So let's start this topic about carboxylic acids. The learning objective. Here we are going to study about the carboxylic acid, and also we are going to learn about the nomenclature of carboxylic acid and the structure and bonding of this carboxylic acid to the different atoms to which it is attached. And also we are going to study the structure, what is the structure of this carboxylic acid and how we can give its name to this carboxylic acid. And the student outcome, we will going to know about carboxylic acid, that what is a carboxylic acid, how many types of carboxylic acid, what is the structure and the molecular formula of this carboxylic acid, how we can name this carboxylic acid, how we can name it according to the common system, according to the IUPAC system. So in this carboxylic acid, we are going to study this as well as the structure of this carboxylic acid and the bonding, what is the bonding in this carboxylic acid. So these are the learning objective and the student outcome which we are going to study today. Next, firstly, the introduction. So, what is the carboxylic acid? In this, the carboxylic acids are aliphatic or aromatic compounds which contain at least one carboxylic group, that is a COOH in the molecule, and the word carboxylic is derived from the name of two functional groups, that is the carbonyl and the hydroxyl. Means here carboxylic acids, these carboxylic acids are aliphatic as well as aromatic. The aliphatic means in the chain also, or the compounds that are in chain, the carboxylic acids are those compounds also, and the organic compounds they are also present on the benzene ring. And these aromatic as well as these aliphatic compounds, these are containing at least one carboxylic group. So they are having one carboxylic group on these compounds, these aliphatic and aromatic compounds. Means here they are having this functional group, that is your COOH group on this aliphatic or aromatic compound. So the word carboxylate is derived from the name of two functional groups. Means this carboxy is derived from the two functional group. This name carboxy is formed by the mixture of the two functional group or the two names, that is your carbonyl and your hydroxyl. Means carboxyl, in this carboxyl there are two functional groups names. From the two functional names, this carboxyl name is derived, or you can say it is completed by the two words, that is your carbonyl and the hydroxyl. So in the carbonyl and the hydroxyl, we can see here from the carbonyl it is taken carbo. So from that carbonyl it is the carbo, and from the hydroxyl it is has taken xyl, XYL. So this is a mixture. This carboxyl is a mixture, or you can say it is derived from the two functional groups, that is your carbonyl and your hydroxyl. So carbonyl is a word that is derived from the name of two functional groups, that is your carbonyl and the hydroxyl. So the carboxylic acids are classified as mono, di, tri, polycarboxylic acid according to the number of carboxylic groups present in the molecule. Means here this carboxylic acid, these are the carboxylic acids are divided. So you can say these are classified as your mono, di, tri, or poly. Means here is one carboxylic group is present, then it is your mono, and if two, then di, if three, then tri, and if so many carboxylic groups, or you can say the functional group is attached to the aliphatic or the aromatic compound, then they are named, or they can classified as mono, di, tri, or polycarboxylic acid. according to the number of, means by saying that the number of carboxyl group that is present in the molecule. Here the number of carboxyl, according to the number of carboxyl group that are present in the molecule, on that basis, these carboxylic acids are classified as your mono, di, tri, polycarboxylic acid. For example, the 1COOH group containing hydrocarbons such as formic acid. Means here, if for example, it is given here that if one carboxylic acid, it means if one carboxylic acid is present in this aliphatic compound or in this aliphatic chain, and then it is that hydrocarbon is known as your formic acid, your acetic acid, your propanoic acid, lactic acid, malic acid, and in case of your aromatic compound, it is known as your benzoic acid. So these that hydrocarbons are called monocarboxylic acid. So these are the hydrocarbons or the compounds that are containing one COOH group. For example, we are given formic acid, acetic acid, propanoic acid, lactic acid, malic acid, and benzoic acid, which is an example of your aromatic compound. So that is known as your monocarboxylic acid. Whereas the two COOH groups containing compounds such as oxalic acid, succinic acid, adipic acid, fumaric acid, malic acid, tartaric acid, halic acid. So these are the compounds that are containing, or these are the hydrocarbons that are containing the two COOH group in their structure. That is why they are known as your dicarboxylic acid. Similarly, like citric acid contains three COOH group and termed as tricarboxylic acid. So here, in the case of your tricarboxylic acid or the hydrocarbons that are containing three COOH group, COOH function group, they are termed as your tricarboxylic acid. These are the three categories here: monocarboxylic acid, dicarboxylic acid, and the tricarboxylic. Fourth is your the long chain monocarboxylic acids are also known as fatty acids, such as stearic acid, palmitic acid, and oleic acid. So the carboxylic acid, the monocarboxylic acid means one carboxylic group is present in this monocarboxylic acid, and they are containing a long chain that is attached to this monocarboxylic acid. They are known as your fatty acids. So they are known as fatty acids. For example, given is there stearic acid, palmitic acid, and oleic acid. So these stearic acid, palmitic acid, oleic acid, which are your fatty acids, they are containing your this long chain monocyclic acids, and that is why they are known as your fatty acids. Fat as well as an acid. So this acid is your monocarboxylic acid, that is, or you can say a carboxylic acid. So the general chemical formula of this aliphatic carboxylic acid is your CnH2n plus 1 COOH. So the general means here the chemical formula of this aliphatic means here we are telling the aliphatic carboxylic acid formula, that is your CnH2n plus 1 COOH. So this is the carboxylic acid functional from a chemical formula. You can write the different structures according to this chemical formula. That is a CnH2n plus 1. It means this CnH2n plus 1 is your formula of the alkyl. As you can study in the last. Also the C is carbon. Here carbon means if N is equals to 1, then C is 1 and H is 3. CH3. CH3 is the alkyl, that is alkyl group that is attached to this carboxylic acid. So this alkyl group is attached to this carboxylic acid. So its name is your acetic acid, which is your monocarboxylic acid, and is containing a one uh, one C double OH group. Again, this carboxylic interaction I'm telling you. So listen carefully that carboxylic acids, these carboxylic acids are your aliphatic or aromatic compounds which contain at least one carboxylic group in the molecule. So these carboxylic acids are aliphatic or aromatic compounds. So these are the carboxylic acids. These compounds are your these carboxylic acids are present in the aliphatic as well as in your aromatic compounds. Both type of compounds are having this carboxylic acid, and they are containing one carboxylic acid. They are containing at least one. That is why they are, if they are not containing a one carboxylic acid, then why we are saying them a carboxylic acid? That is why this aliphatic or aromatic compound, if they are containing this one um, carboxylic group in the molecule, that is this COOH is the functional group of this carboxylic acid, then it is known as the carboxylic acids. And the word carboxyl is derived from the name of two functional groups. As you can see in the structure of this functional group, also COOH, and in the name also, that CO is your carbonyl that we have studied in the aldehydes and ketones, and OH is your hydroxy. So the word is also containing the two name of the two functional groups, that is the carbonyl and the hydroxyl. So this carboxyl as well as the functional group structure is also containing the two functional groups, that is your carbonyl and the hydroxyl. So here you can see this is your carbonyl, the C double bond O is your carbonyl, and this OH is your hydroxyl. And in this carboxyl also, this carbo is your carbonyl and oxyl is your hydroxyl. So the word carboxyl is derived from the name of two functional group, that is carbonyl and hydroxyl. So the carboxylic acids are classified as mono, di, tri, or polycarboxylic acid. So these carboxylic acids are classified as mono, di, tri, or polycarboxylic acid. So these carboxylic acids are classified, or you can say are divided into four categories. That is your mono carboxylic acid, dicarboxylic acid, tricarboxylic acid, polycarboxylic acid, and according to the number of carboxyl groups that is present in the molecule. If uh, if these are classified according to the number of carboxyl groups that are present in the molecule. So the molecule, if the molecule is containing one carboxyl group in them, then that is your monocarboxylic acid. If it is containing two carboxylic acid, then it is your dicarboxylic acid. If it is containing three carboxylic group, then it is your tricarboxylic acid. And if it is containing your poly, means more than three carboxylic group in their structure, then that is your polycarboxylic acid. So according to the number of carboxyl group present in the molecule, these carboxylic acids are classified as mono, di, tri, or polycarboxylic acid. So for example, here given one COOH group containing hydrocarbons such as formic acid, acetic acid, propanoic acid, lactic acid, benzoic acid, etc. are called monocarboxylic acid. Why they are monocarboxylic acid? Because they are containing this one COOH group in them. So these COOH group, if one COOH, if one COOH functional group is present in this in these compounds or in these hydrocarbons, then they are your monocarboxylic acid. So these are your formic acid, acetic acid, then your propanoic acid. So that is why they are your formic acid. And this benzoic acid is your aromatic compound. This is your aromatic compound. This is containing a benzoic ring, and on that benzoic ring, there is a functional group that is your COOH. A functional group is attached on this benzoic acid. So this benzoic acid is a aromatic monocarboxylic acid compound. So this is containing one carboxylic group on this benzoic acid. And whereas the two COOH group containing compounds such as your oxalic acid, succinic acid, adipic acid, fumaric acid, malic acid, tartaric acid, halic acid. So these compounds, they are containing the two COOH group. So these compounds, that is, these oxalic, succinic, adipic, fumaric, malic, tartaric, halic, these are the compounds that are containing your sorry, two COOH group. So that is why they are called dicarboxylic acid. These these citric acids, if they are containing three COOH group, and they are termed as tricarboxylic acid. So if they are containing the two carboxylic group present in their in their chain, then they are your dicarboxylic acid. And if they are containing the three carboxylic group are present, then firstly the name is given to them. After that name, the suffix is applied, that is your 3-carboxylic acid. So the long chain monocarboxylic acids are also known as fatty acids. So the long chain compounds, this long chain aliphatic compounds, these are containing one carboxylic group in their structure, and these are known as fatty acids. Also, the long chain the long chain is given the name fatty, and due to the presence of this monocarboxylic acid in these long chain and this fatty, these are known as acids. So these fatty acids are containing the long chain monocarboxylic acids, and these are known as these, such as, for example, we are given stearic acid, palmitic acid, and the oleic acid. So these are the fatty acids. So fatty acids are containing the fat as well as the oil. So here the two types, two are the fat oil and one is your fat. So the general chemical formula of this aliphatic carboxylic acid is your CH2N plus 1 COOH. So the formula that is of this aliphatic carboxylic acid is your CnH2n plus 1 COOH. So this aliphatic carboxylic acid is having the general formula, that is your CnH2n plus 1 COOH. So Cnn is the number. So number, if n equals to 1, then CH3 COOH, then its name is your acetic acid. If C is 0, then H is your 1, and then H is your 1, then the name is your H, then the structure will be your HCOOH. So this HCOOH, then the name of this acid is your formic acid. So formic acid is not having only one carbon atom is there, and the acetic acid is having the 2 carbon atom, and the propanoic is having the 3. So if there is a one more CH3 is attached, CH2 is attached to this group, then that name is your propanoic acid. So this is the introduction of this carboxylic acid. And in this topic, we are going to study about the nomenclature as well as the structure of this carboxylic acid and about the bond also of this carboxylic acid. So, so now let's uh, so the nomenclature of this carboxylic acid. So in the IUPAC system, carboxylic acids are named by replacing the suffix E of the corresponding alkane with oic acid. So in the IUPAC system, you have to name this carboxylic acid, and then this carboxylic acid and these carboxylic acids are named by replacing the suffix E of the corresponding alkane with oic acid. So we have to name it. In this carboxylic acid, we have to name this carboxylic acid in this IUPAC system. In this IUPAC system, if we have to name this carboxylic acid, so we have to replace the suffix E, E from the alkane, E from the alkane, from the corresponding alkane, and by replacing this E, we have to use a suffix that is your oic acid. So this oic acid uh, is is given when the carboxylic acid is present in the chain or in the aromatic compound. So it is not necessary to indicate the position of the COOH group because this group will be at the end of the parent chain and its carbon is assigned as carbon 1. So this according to the priority sequence in the IUPAC system, this this carboxylic acid is having the highest priority in the priority sequence table. So if it is present, if it is present in the ring or in the chain, then give we have to assign the carbon that is present in the carboxylic acid as 1. So here it is not necessary. So in this case, it is not necessary to indicate the position while writing its name. You do not have to indicate the position of this carbon because it will always will be added on the first, or you can say it will be assigned as a first carbon in the chain. So it is not necessary to indicate the position of the COOH group because this group will be at the end of the parent chain and its carbon is assigned as carbon 1. So इसके carbon will be assigned as your carbon 1 if it is present in the parent chain, and it will always be at the end of the parent chain. From that side, from that carbon that is in the carboxylic group, we have to start the numbering from that carbon. So the common names and IUPAC name for some straight chain saturated carboxylic acid are given in table this. So here in table, you can see the names and the IUPAC names and the common names of this straight chain saturated carboxylic acid. Saturated carboxylic acid means that the chain that is containing the your aliphatic, this chain is containing your single bond compounds. Saturated carrier single bond means your alkane, not the double or the triple bond, that is your unsaturated. So this here you can see the two names are given, that is your HCOOH. So this HCOOH, the common name of this carboxylic acid is your formic acid and the IUPAC name is your methanoic acid. So how it is named methanoic acid, as you can see in this structure, that this is your H and this is your COH. So this COH, so the formula for writing this structure is your CnH2n plus 1 COOH. So in that case, N equals to 0, and if N equals to 0, then H equals to 1. So this H, then COOH. This is the functional group of this carboxylic acid. and its common name is formic acid. So in the common name, we have to use this suffix ic. Um, and in the IUPAC name, we have to use this suffix oic. So this is your oic, and this is your methane. From methane because one carbon atom is there. So methane, from methane, E is replaced. E is replaced by your oic acid. So when E is replaced by the oic acid, then it is your carboxylic acid. Now the second example is your CH3COOH. In this case, the carbon, the N equals to your 2. N is your 2. So the N is your 1. So C is your 1 here. This H is your 3. Then this is your carboxylic acid that is attached to this CH3. So this common name is your acetic acid. So for the two carbon, we use the word acid. And it is your it is suffixed because it shows the presence of your carboxylic acid. So this is your acetic acid according to the common name. And according to the IUPAC name, it is your ethanoic acid. Ethanoic means that two carbons are present here and a group is present here. So from ethane, E is replaced by your oic acid. So that is why its name is your ethanoic acid. So in this IUPAC system, the carboxylic acids are named by replacing the suffix E of the uh, corresponding alkane with your oic acid, and it is not necessary to indicate the position of the COH group. So in this carboxylic, in this while naming the IUPAC system, according to the IUPAC system, we have to name the carboxylic acid by replacing the E from the alkane, and after replacing this E, we have to use the suffix that is your oic acid. So in this example, we have already seen, and it is not necessary. It is not necessary to indicate the position. As in this case, we have not indicated the position because we know that this COH is present on the end of this parent chain. So the numbering will start. This is your first carbon, then this is your second carbon. 1, 2. So here it is not necessary to indicate the position of the COOH group because this group will be end at the parent chain and its carbon is assigned as C1. So the carbon that is present in the COOH, is this will be assigned as 1 because this group will end at the parent chain and its carbon is assigned as C1. And because of in the priority sequence that is in the IUPAC system, the carboxylic groups are having the highest priority in the priority table. First group that is present on the first position, that is your carboxylic acid. So it does not need any numbering to show that it is present in this position. So because the naming will or the numbering will start from that group only, because it is present in the highest priority in the priority sequence. That is why this carboxylic acid is not assigned, or it is assigned but it is not given any number in the when we are naming its when we are writing its name. So this is the nomenclature of the carboxyl. Some few examples are also there in the next slide. Let's start. Now this is your second. So in the second, you can see here CH3, CH2, COOH. So here, according to the common system, its name is your propionic acid. So ic acid. So in case of common, its name is your propioin. Propioin. So this is the common system of this naming. First is your form. Second is your acid, and third is your propion. And in this, the suffix that is applied is your ic acid. So here the carbon number is your 3. No, 2. two carbon number is there. If n equals to 2, then carbon equals to 2. Okay, 2, then H equals to 5. 3 2 6 1 7 3 2 5. So here C equals to your 2 and H equals to your 5, 2 to 4 or 1 5 and C double OH. So its name is your propanoic acid because the you can count it from here 1, 2 and 3. This is your 1, 2 and 3 and this 1, 2 and 3 name is your propanoic acid. This is your propane. Because the three carbon atoms, we name it propane. And from propane, E is replaced and OH is added to this position. That is why its name is your propanoic acid. Next is your CH3, CH2, CH2, COOH. This whole two means here two CH2 are present. So here its name is your butyric acid. So it is your butyric and ic we applied here, its name is your butyric acid. So here you will see that the carbon is having the three carbon atoms. So 3, P3 and H will be a 7. So here you can see H3, 4, 5, 6, 7. So this its name is your butanoic acid. So this is your butanoic acid. This is your butanoic acid. So here this is your CH3, CH2, 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 COOH. So if this carbon, the carbon is 3, 4. 4 carbon atoms and one this 5. So its name is your valeric acid. So this is your valeric acid. So this valeric acid here, valeric is used when there is 5 carbon atoms there. And it is used because there is a carboxylic acid present in this group. So here this is your valeric acid according to the common name, and here this is your pentanoic acid. So in this pentanoic, because C is having the 4 carbon atom and C4, this is your 3 carbon and one is this 4, C4 H 10 3 3 6 7 8, sorry 8. So this is having 3 3 to the 6 6 plus 1 7. 3 3 6 7 8. So here 8 is there. This is your 4 C4 C4 4 2 4 is 8 and 1. So here it should be your how many C3 CH2 CH2 CH3 3 2 4 5 6 and 6 7 8 9. So this is your 9. This is C3 H9 COOH. So this is your pentanoic acid. Next is your this is your C4 or C4. So C4 is your C4. So here C4 4 and this is your C5. Sorry, this is your C5 and H is your 3 2 4 5 6 7 8 9 and here 10 and here if we use 4 5 then 5 12. So here this is your C3 CH2 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 CH2. So 4 are there. So here 4 5. So 5 carbon are there. 5 to the 10 and 1 11. So here 4 5 8 9 10 11. So here 11 hydrogens are there and one COOH group is present and its name is your caproic acid and it is your hexanoic acid. Next is your CH3, CH2, CH2 and the 5 carbon atoms are there, means the 5 carbons are there and one is your 6, then 6 and 6 to the 12 or 113. So here 13 hydrogens are there and one this is name is your, if 6 carbon are there then its name is your haptane and E is replaced by your oic acid, then this is your haptanoic acid. Again this is having a 8 carbon atom and this 8 carbon atom containing the name caprylic acid and according to the IUPAC system its name is octane and the octane is having E is replaced by your oic acid. That is why its name is octanoic acid. Next, it is your 9 carbon atom, and in this 9 carbon atom, its name is your pelargonic acid. Pelargonic acid. So, according to the common name, the 9 carbon atom containing compound is your pelargon, and ic is applied to it, and this is your ic acid, that is your pelargonic acid. And in this the according to the IUPAC, its name is your nonane, and in this the nonane, the nonane is its name, and E is replaced by your oic acid, and this is your nonanoic acid, and this chain is containing the 10 carbon atom, and from numbering will start from this side, and this is their 10 carbon atom, and according to the common name, its name is capric acid, and it's here it is your decanoic acid. So this is your decanoic acid. Next is your CH3, and this is your 11. That is why its name is undecanoic acid. And this is your 12. So it is your lauric acid, and its name is your dodecanoic acid. Dodecanoic acid means 12 carbon are there, and 12 for the 12 carbon, according to the IUPAC name, its name is dodecane. So dodecane, E is replaced by here, and its name is used oic acid. So this is your dodecanoic acid. Next, the IUPAC system nomenclature of dicarboxylic acid. That's they were the example of your monocarboxylic acid. So these are the example of your dicarboxylic acid. So if there are two COOH group of are present in an acid, the acid is called your dicarboxylic acid. So to construct the IUPAC name, here we have to use the suffix, that is your dioic acid. So the suffix dioic acid should be applied to this IUPAC name, and to the name of the parent alkane containing 2 carboxylic acid. These 2 carboxylic acid are present in this chain. So its name is your dicarboxylic acid, or you can say dioic acid. So the first example is your carboxylic acid is your COOH. That is your, according to the common name, it is oxalic acid. But according to the IUPAC name, as you see here, the two carbon atoms are present here, and these are the 2 carboxylic acid. That is why it is named as your ethane. Those 2 carbon atoms are there, and we have used here dioic. Its name is ethane dioic. So this is your dioic acid. So this ethane dioic acid. Second is your CH3, CH2, COOH. So this is also having the 2 carboxylic group, but it is also having, you can see here that the 3 carbon atoms are there. For 3 carbon atom, we use the word propane, and according to common name, its name is malonic acid. So it is your malonic acid, and its IUPAC name is your propane dioic acid. Next is your COOH, CH2, CH2, COOH. So its name is your succinic acid. So its succinic acid is your, according to the IUPAC name, its name is your butane dioic acid. So it is containing the 4 carbon atom. That is why its name is butane dioic acid. So in the adipic acid is a name which is having the 6 carbon atom, and its name is hexane dioic acid. Next is your malic acid. So in the malic acid, as you can see, there is a double bond in it. So here, if it is having a double bond, then its name is your, and it is, as you can see here, cis and trans, that it is, these groups are present on the same side. That if they are present in the same side on the C double bond C carbon, then we have to use your cis. So it is your cis 2-butene dioic acid. As you can see here, we have used butane because here single bonded are between these carbon atoms. But in this case, between these two carbon atom, here is a double bond. That is why we have used the word butene dioic acid. Its name is butene dioic acid. Next, you can see here the group are on the opposite side. This H is also on the opposite side, and this COOH is also on the opposite side. So its name is trans 2-butene dioic acid. So it is your trans. Name is same. They are having the same molecular formula, but the structure is different. So this is the cis and this is the trans. This form is known as malic acid and the trans form is known as fumaric acid. Next is the IUPAC nomenclature of hydroxyl derivatives of carboxylic group. Means here the hydroxy group is also present. So here the hydroxy derivatives of carboxylic acid are called hydroxyl carboxylic acid. So these are known as hydroxyl carboxylic acid because these are the hydroxyl derivatives of this carboxylic acid. So in the common position, in the common system, the position of OH group in a hydrocarbon chain is indicated by the Greek alphabets, that is your alpha, beta, delta, gamma, etc. Whereas in the IUPAC system, the position of OH group in a hydrocarbon chain is indicated by the number 1, 2, 3, 4, etc. So in the table you can see here the hydroxyl, these we have to name, we have to nomenclate according to the IUPAC this hydroxyl derivative. Hydroxyl derivative means that in the chain there is a carboxylic acid is also present and the hydroxyl group is also present. Means OH group is also present and the COOH group is also present. So the hydroxyl derivative of carboxylic acids are called hydroxyl carboxylic acid. And in the common system, this OH group is indicated by the Greek alphabets, that is alpha, beta, gamma, delta. But according to the IUPAC system, in the IUPAC system, the position of this OH group is indicated by this 1, 2, 3, 4, etc. So here the names are given. The carboxylic acid, so a common name, its name is glycolic acid, and its IUPAC name, its name is hydroxyethanoic acid. Next, here we have to show the position of this hydroxyl group. So here we have written 2-hydroxypropanoic acid, and it is your lactic acid. Next is your malic acid. So in this malic acid, you can see the hydroxy is present on the second position. Its numbering will start from this carbon 1, 2, 3, and 4. So on the second position, this hydroxy group is present. So its name is 2-hydroxybutane dioic acid. It is 2 carboxylic acids again. So here you will see CHOH. So here 2 groups are present which is having the OH group. So that is why we have named it 2,3-dihydroxybutane dioic acid. This is the example of your citric acid, and in this you can see, so in the citric acid you can see here that this is having the 2 on the second position. On the second position, as you can see, this is from this side. In the second position, on the second position, the hydroxy group is present, and there are 3 carboxylic groups are there. So here you can write here 2-hydroxypropane because it is having 3 carbon atoms. 1, 2, 3 tricarboxylic acid. So it is having the 3 carboxylic acid present on the 3 carbon atom. That is why its name is your 2-hydroxypropane 1, 2, 3 tricarboxylic acid. So this is the IUPAC nomenclature according to the of the hydroxyl derivatives of carboxylic acid. Next is your, if the carboxylic group contains double bond, then replace the in from A to E, and the replacement of the infix is determined by the numbering. If this is present double bond is in this, then this name is your butanoic acid. So A, we have to use the word ene in place of this ane. So here ane is converted into ene. So this is your butanoic acid, this is your propanoic acid, and this is on the hydroxyl group, this benzene ring. So name is your 2-hydroxybenzene carboxylic acid. Next, if 2-carboxylic acid groups are present on this benzene ring here, you can see this is having a 2-carboxylic group. So its name is 1,4-benzene dicarboxylic acid, because in the first position and the fourth position this carboxylic acid is present. Next, structure and bonding. So in the structure and bonding, you can see here the carbonyl group is present, and on the another side this hydroxyl group is present. So the carboxyl group in a carboxylic acid is constituted by a carbonyl group and a hydroxyl group. The carboxyl group carbon atom is double bonded, and one oxygen atom is single bonded with another oxygen atom in a carboxyl group is shown in the figure. So here you can see this is the carbon which is attached to this oxygen atom with the double bond, and this carbon is attached to this oxygen with the single bond. So the carboxyl group can be represented by RCOOH or RCO2H. So the carboxyl carbon in a carboxyl group is bonded with the three functional groups, 1, 2, and 3. There the carboxyl carbon, this carboxyl carbon is sp2 hybridized. This carbon is a sp2 hybridized, and this carboxyl group has a planar structure. So this is having a planar structure, and it is approximately 120 degrees. Here the angle between this is 120 degrees. In a carboxyl group, the COO bond length is shorter than the bond length between it now. So it is having a shorter bond length because it is having a double bond, and it is shorter than your C single bond O. So one half filled unhybridized p orbital of the carbon in the hybridized p orbital of the oxygen atom overlap sideways. So these are overlapping with the sideway p orbital. So this results in the formation of delocalization p cloud. So here is the delocalization between this and the C single bond O in formic acid is shorter than the C single bond O length in ethanol. So this is the carboxylic acid, and this is polar bond due to the presence of this OH group. And the resonating structure of this is here. That this is the resonating structure, and the third is the resonating structure as all the atoms with the full quota of electrons, and first is most stable, and this is the most stable form. And this is second is your positively charged, and carbon is your positively charged, and is having only 6 electrons in its valence cell. So it is the important resonance structure that is your first and second, and that are electrically neutral. And this carboxyl group is also polar due to the resonance structure that is your second and the third. Now the questions. The RCOOH group donates carboxylic acid, that is option C. B. Next, which of the following is a carboxylic acid? That is your acetic acid. A. Which of the following pair does not show an acid and its conjugate? That is your C. Which compound is more acidic? That is your D, H2S. Which compound is least acidic? That is your A. Which class of compound is an example of a carbonyl compound? That is your carboxylic acid. The pK value is equivalent to B minus log A. The pK value of acetic acid is itna, and HCl is your minus 7. Which of the following is a stronger acid? That is your acetic acid. Which of the following has the highest pK? That is your hydroacetic acid. These are the references from where you can study this topic. These are the references. And thank you so much for today's lecture. We will continue it in the second lecture.